So is it possible to use this one?
That's the pointer, so raise it.
Okay, so good morning. Okay, so good noon, I think. My name is Jinglu. I'm from the Xi'an Jiaotong-Liverpool University, and it's my honor to give a presentation here. And the topic today is about the urban green and blue space and heat-related mortality in high-density cities. So I think it's a very hot topic, right? So particularly during the recent time, as you know that there is multiple heat events occurred, right? So in different cities all around the world, right? And also during the recent times, the nature-based solutions is very popular, right? So because it could, due to its high cost benefit, right? So sorry about that. Yeah. So firstly, let me just introduce some background information. Right. As you know, that the climate change, through the catastrophic impacts of extreme heat, continues to pose a threat to the global health. And here I just show a figure, right? So this is a result of the multi-country and multi-city, right? Study, right? So you can see the distribution map of the heat-related mortality all around the world. And here, right, so in the East Asia, right, so there is hotspots within this area. So that also indicates the heat-related mortality is very crucial, right? So the threaten, right, to the local population, and also reportedly the 9.1 out of every 1,000 days attributable to the extreme heat globally. This is a most recent study, right? So the results of the most recent study. Okay. And in addition, the heat-related excess mortality risk is projected to increase continuously in the future, right? So according to a previous study, right? So in the multi-city and multi-county, right? So study. And here. So this particular figure just to show the. Here's the point. This one, okay. So this small figure are just to show the condition in the Southeast Asia. Right, so you can see that the excess days due to the heat is rapidly increasing. Right, so under the RCP 8.5 scenario. Right, so that indicates the extreme heats, right? So it's a very crucial threat, right? So to the population, particularly within the Southeast Asia. Okay. And in metropolises with high density and high rise environments, the adverse health impacts increases as the climate warms. This is a projection of the daily mean temperature in the future, okay, and are exacerbated by the urban heat island, right here. So because as we know that due to the urban heat island, right, so the urban area is heated, right, so but it is heated, right, so compared to the rural area, okay. And a poor thermal environment have contributed to significant health risks, especially for the older adults living in the urban area. So this figure just to show the projected, right, so elderly, right, so in Hong Kong, right, so the study area in the future. So you can just compare the columns, right? So the pink column just represents the percentage of old population in 2019, and the red column just represents the percentage of the old population 10 years later. So you can see there is a big difference, right? So between the current years and in the future. So and the aging population, right, in Hong Kong also depicts an aging society that would become a hotbed of heat-related mortality. Okay, so that is also why I selected Hong Kong as a study area. Okay. So, there is a pressing need to evaluate strategies that may mitigate against further increases in temperatures and the associated negative impacts on the human health, particularly for the high-density cities with an aging society, just like Hong Kong. And urban greening and bluing is increasingly recognized as one nature-based solutions. Right, so it is very popular concept all around the world, and the mitigation strategy to combat the heat impacts on the population health. But the question is, because as we know that for the green space, right, so it could cool the city, right, by evapotranspiration and the shading effects. And for the blue space, right? So it could also cool the city by evaporative cooling or through the land sea breeze. But on the other hand, right? So the some previous studies also shows reported that the green and blue spaces will increase the outdoor activities, right? So that indicates the people may suffer, right? So the higher amount of heat exposure, right? So because they just do conduct more outdoor activities. Okay, so there may be a trade-off, right, between the benefits and also the maybe the some drawbacks, right, so of the green and blue spaces in case of the heat mitigation. Okay, so for the research gaps, right, so we just found the epidemiological evidence for effective modification of green and blue spaces on heat mortality associations remains limited. And moreover, the effective modifications of green and blue spaces under different levels of heat, right? So just like we just named it as a moderate heat, right? So with temperatures over the 90% right, of temperature distribution, and the heat events that just indicates days with temperature over the 95% of temperature distribution. Okay, so we just wonder, right? So if there is a very effective modifications of green and blue spaces on the different levels of heat, and also among the different age and sex groups. So those are the research gaps, and yeah. So this slide is just to give a brief introduction, right, of the study area, right? Because Hong Kong is the world's fourth most densely population city, right? So it's very crowded, and also it's the civil environment is is poor just due to the urban heat island effects, the global warming, and it's hot and humid the local climate. Okay, and also because the Hong Kong is experiencing an aging society, right? So the percentage of old adults, right? So was over 15%, right? So more than double, right? So the percentage of old adults in an aging society, right? So we could foresee, right? So the threat, right, from the extreme heat on the local population health. So for the data collection, we just collect the daily temperature and the relative humidity, right, from the Hong Kong observation station, because this station just have a complete data set, right? And also we collect the air pollution data, right, so from the 11 monitoring stations. We just excluded the roadside ones, okay? And for the mortality data, we collect the daily non-days micro data set during the summer months, because we focus on the heat events. And we also consider the social demographic data, right? So particularly, we just try to use them to control for the confounding effects. And for the two major green, the level of green and blue space, we use NDVI, right? So this is widely used remote sensing data. And also we calculate the distance to the coast as proxies of the blue space exposure. Okay,
5 minutes.
5 minutes. Okay, thank you. I will try my best.
Yeah.
But yeah. Okay, so firstly, we try to just to explore, right? So the lag effects of the heat events. So we use a widely used lag response, the distributed lag nonlinear model, right? So here is some parameters we used. We just skip this the details. And so for the prediction results, right? So we try to calculate the relative risk, right? So at the 90s and 95% percentiles compared to the derived minimum mortality temperature, right? And try to calculate the relative risk. So later I will just show you some results. Okay. And in the second step, we try to include, right? So we try to use interaction modeling, right? So and to calculate the effect modifications of the green space and blue space, and because the time is limited, so I will not introduce the details, but the work has already been published, right? So in a journal article. So if you have interest in the details of the model, right? So you can just download and read it, right? And for the prediction results, we just focus on the estimation, right, so of this interaction term, right? So because this interaction term just represent the difference in mortality per 1 Celsius increase in the lag time above the threshold value of units at different levels, right? So of either the green or blue space. And we just use a p-value smaller than 0.05, right? So to explore the significance. So to explore the effective modifications by the different age and gender groups, we also conducted stratified analysis, right? So by the different levels of heat and by gender and age groups. We also conducted the sensitivity analysis by changing the maximum lag days, by changing the date for the arrival time, and controlling for the relative humidity and air pollutions. And we also try to set the different cutoff values of NDVI and the distance to coast, right? So to see, right, if our results are robust, right? So, and I will just show you some results quickly. Okay, so this is a lag response relationship between the hot temperature and mortality. So accordingly, we can see that actually, right, so the lag effects mainly, right, so occur at the 022, right, so the heat exposure on the same day and the previous 2 days, right, so that was significantly associated with the increase in mortality. So here we just count these lag effects in our interaction model. Okay. Yeah, so this is a result, right? So the mortality risk under the moderate heat and heat by exposure levels to the green and blue space. So we can see that even though between group, the difference is not significant, but right, so we can see that the point estimation is highest, right? So at the area with at the lower level of green space, okay, and also right, so similar results were observed for the blue space exposure. Okay, so this is the results of stratified analysis. Okay, so by the different age groups. Okay, so we can see that the trend right, so remain for the old adults. Okay, this is the total. This is results for the total population. This is results for the old population. And but we didn't find a significant difference, right? So to the different age groups. Okay. And also the so discussion. I will just
this is
I will just quickly just
essence. The essence.
Yeah. Thank you. Yeah. So finally, we didn't find a significant effect modification of green and blue space, but right. So but we this is inconsistent, right? So with previous studies, right? So we just think that the difference, right? So maybe just due to the maybe the empirical studies conducted in different climate zones, the cities, and also the other characteristics of blue and green spaces, but that doesn't indicate, right? So the well-designed green and blue spaces will have no effect, right? So on the heat mortality reduction, right? So further studies also need to to be conducted. Okay.
Oh,
Yeah.
sorry. So the time is up. So sorry.
Okay. So wait a minute. Okay. Sorry about that. Just 1 minute. One more minute. Okay. Sorry about that. Yeah. So just try to This is the our paper has already been published, right? So here, so if you have a strong interest, right, so you're welcome to download and view the see our article. And this is my contact information, so please let me show my contact information and the relevant publications. So if you have interest, you can just take a photo, as I think. And I welcome any chances to cooperate with you if you have interest, right? So in my research, yeah. Okay. That's okay. So any questions is welcome.
After the sessions.
So now is the Q&A session. Okay.
Yeah. So thank you, Dr. Linda. So we finish now because
Okay. So no question.
We can have room later.
Okay. So thank you.
So exceeded the time.
Yeah.
So our final speaker for today is Geraldine Molina and colleagues on population vulnerability and resilience analysis model to urban climate in the context of climate change.